In this video we'll work through the 2021 Diff Calc test. 50 marks, you had 50 minutes to do it, and some of you guys struggled to do it within that time frame. Not surprised, given that so much of this year has been remote learning and remote tests, which you had a lot longer to complete. So let's see how we go and see if I can knock it out in under 50. Okay, so question 1, water is being poured into the open container shown below at a constant rate. Sketch the graph showing the height of the water over time. So this section here, the height will increase at a linear rate. And then this bit here, what we'll get is a slower increase and getting faster. So something like this would be appropriate. Okay, state the derivative of the following functions. G dash t is equal to -4. This one needed the negative index rule, so we'll just write f of x with a negative index first, and then it's ready to derive. You didn't have to write it with a positive index, but that was fine if you did. Just watch the further engagement. That would be correct. If you stuffed up the rewrite to the positive index, you can't get that mark because that's called further engagement. So I can't pretend that it didn't happen. All right, so this one here, students found difficult. What you had to do with this one, again, we don't know how to derive a function over a function just yet. So you had to get this to single terms, and the way to do it was to note that a quick factorize of the numerator, 5 and 2, x take 5, x plus 2 over x plus 2. We'll chop that out, giving us y equals x take 5, and then we can do our derivative dy dx equals 1. Okay, find the equation of the tangent to the curve blah 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 at x equal 2 in the form y equals mx plus c. Okay, so for this one, what we'll do is actually get the gradient of the tangent at x equals 2. To do that, we'll need to find the derivative of this and then bang 2 into the derivative. So I'm just going to use function notation for this. Let y equal f of x. F dash x equals, so that's 2/3 x take away 2, and let's do f dash 2. That's going to be 4 on 3 take away 2, which is 4 on 3 take away, what's that, 6 on 3, negative 2/3. So the gradient of the tangent at x equals 2 is negative 2/3. Now that's good, but we're not after the gradient of the tangent, we're after the equation of the tangent. So we know that it's got a gradient of negative 2/3, and to get its equation, all we'll do is put 2 into the original function. So we're going to go f of 2 to find out the y value at that point. So that's going to be 2 squared is 4, 4/3, take away 4, bit of fraction work in this one, negative 8 on 3. So the equation of the tangent goes through the point 2, negative 8 on 3. So what we've got here is a gradient and a coordinate that allows us to get the equation of the tangent. So I tend to like using y take y1 equals m x take x1. You don't have to use this. Now what we'll do is note that that's going to be the y value. This is going to be the gradient. Okay, so this would be acceptable as the equation if it didn't say to put it in this form here, but we need to further engage with this. So it's going to be y equals negative 2x on 3 plus 4 on 3 take away 8 on 3, which is equal to 2x on 3 take away 4 on 3. Okay, given that h of x is continuous, show that a equals 3. So it's 3 and 3. Basically saying, can you show me that it's continuous at x equals 3? So the way we'll do this is that both of these should intersect at x equals 3. So let's let them equal each other, and then when we solve it, it should be x equals 3. So we'll go 8x take away 27 is the same as 3x squared take away 10x. Now that's going to be 0 equals 3x squared take away 18x plus 27. Alright, let's dump the 3. That's going to be 3 x and negative. 0 equals x take 3 squared. And solve it. X equals 3, therefore a equals 3 as required. Okay, find h dash of x. So we need to get the derivative of this function here. So we're going to go h dash x equals, the derivative of this one is 8. The derivative of this is 6x take 10. Now it's going to be a 3 and a 3. Now, do we include 3 or do we not include 3? And you might have heard me say that it's not included or it is included. The only way we can do this is test the gradient from the left and the gradient from the right at x equals 3 and see whether they match up. Alright, so what we'll do is 3 from the left is 8 and 3 from the right, 6 times 3. So what I'm going to do, I've just sub x equals 3 into this one. So I'm approaching from the left-hand side and it says my gradient is 8. Now I'm approaching from the right-hand side, so sub x equals 3 into that one. And it's 18, take 10, which is 8, which means that we've got the same gradient as I approach from the left and the right. So therefore, we can say greater than and equal to 3 and less than 3, or we can do it the other way around. It doesn't really matter. So we can do that. All right, so we can say that officially the gradient at x equals 3 was 8. Now, I think a lot of you guys got this correct only because you just copied out the domains over here. But don't forget to just test your differentiability of h dash x when it comes to composite functions. Okay, consider the function f of x equals that. Determine the values of x for which f dash x equals 0. Okay, so this one here will go 0 equals. Now, what I'm going to do is just get rid of this denominator by factoring out x in the numerator. So that's gone. And I won't let it equal 0 yet. So that's wrong, because that's just f of x. Now I'm ready to derive. Oh, come on. Okay, so determine the values of x for which the gradient is 0. So basically just gave that a bit of a nip tuck because I wasn't ready to derive it in this form here. Derived it, set the derivative to 0 to go hunting for a 0 gradient point, and it goes, I've found a 0 gradient point. It's at x equals 1/3. All right, so we know that f of x is this function here. So that's an inverted parabola. We know that it's got a 0 gradient point at x equals 1/3. So we're going to say that the function f of x is strictly increasing, where x is an element from negative infinity all the way up to the stationary point. And remember, with strictly increasing, what we do is if we choose any two values over this domain here, the second value will produce a y value larger than the first value. Therefore, we would include the stationary point for strictly increasing. Now remember, if this question is when is f dash x greater than 0, we don't include that, because this basically is the question, when is your gradient positive? Okay, and it can't have a positive gradient at a 0 gradient point. So don't forget that strictly increasing is different from when is the gradient positive. Okay, given that f of x equals that, find this. So basically, where this is working out the gradient between 2 points, x plus h and x. Okay, so what we'll do is just pop them in. So we've got 2x plus h squared plus 1, take away 2x squared plus 1 over h. All right, we'll expand the perfect square. All right, my writing's a bit big here. Oh, I'm running out of room. That's a shocker. Probably thought I was going to knock that out in one line. Okay, here we go. I'm just going to try and use this space here. Okay, so what have I done wrong? All right, so now I'm about to make a mistake, because the plus 1 and the plus 1 is not going to cancel out, and the constant needs to go for the derivative. And I can see here, I've even bracketed this, and I've still stuffed that up. Subtract that, and it should be subtract that 1. So I'll leave this in, because it's important for you to see mistakes when they come about and how you know that they're mistakes. All right, so gone, h can come out, so that's great. 4x plus 2h over h, and that's our answer there. So this f of x plus h take away f of x over h is just 4x plus 2h for this function. Now, what they want us to do is set the limit as h approaches 0. So if we do that to this, so we'll go lim as h approaches 0 for 4x plus 2h equals, so that will get to 0, so that's 2 times almost 0, so we're left with just 4x. So essentially you can see there that we found the derivative of that. It's first principles. Okay, find the coordinates of the stationary points of the function and hence sketch the following showing all key points. All right, so there's our function. Okay, so it's got a y-intercept of 16, and it's a cubic, it's a quartic, it's a positive quartic, so positive quartics will start like a parabola. So what we'll do is, I think, just get the derivative. Okay, that looks good. We'll set that to 0. Whoops. Factor it. Okay, so null factor law time, 4x equals 0, so x equals 0, and this one here, we've got x squared take 4 equals 0, x squared equals 4, x equals plus or minus 2. Okay, so what that means is it's got stationary points at 0, at plus or minus 2. All right, so how do we go about this then? So what's going to happen is the parabola is going to, or the quartic is going to come down like this. It's going to turn somewhere at x equals -2, come back, has to turn at x equals 0, so it'll turn on this point here, and then come back down. So all we'll do is find out where it turns at x equals -2 and x equals 2. So we'll go f of -2. Now that's going to be 16. No, it's not. 3, 2 to the 4 is 16. Yeah, it is. Take away. That's going to be 4. 8 4s are 32. Plus 16. So 0. F of -2 is 0. And no doubt there will be some symmetry with this. That's going to be 16. Okay, so what it does... So basically what I've found out is that the turning points, the y value is 0, which means it turns on the axes. And I could probably tell that by actually factorizing that. Actually, let's do that as well. Sort of disappointed I missed that. So we've got x squared, 4, and 4. That's negative, negative. So the factorized version of f of x is x squared take 4, x squared take 4. And we can see that's, if I set that to 0, we're going to get x equals -2. So that gives us the x-intercepts. So we know that the x-intercepts are 0 gradient points as well. So yeah, a few different ways of doing this, but it was a difficult graph, no doubt. So it comes down, goes through there, comes back up again. All right. Okay, the last question. Find two positive numbers, the sum of which is 8, and such that the sum of the cube of the first and the square of the second is as small as possible. All right, so this is what we're trying to make a function where the sum is as small as possible. So this is the thing that we want to minimize. So we want to get it in terms of either y or x. I'm going to go for... I'm not going to do in terms of y because I think that will mean I have to expand a cubic to derive. So let's do y equals 8 take x and put that on for y. So I've got x cubed plus 8 take x squared equals, what are we going to call the function? We'll just call this f of x. Okay, we've got x cubed plus x squared, take away 16x plus 64. F dash x, so we're trying to minimize the sum, so set that to 0 in a sec, so it's going to be 3x squared plus 2x take 16. 0 equals 3x squared plus 2x take 16. 3x x. What am I I trying to make 2? I think that's the configuration. 6, 8, and we want positive 2. So we need that. So 0 equals 3x plus 8, x take 2, x equals 2, x equals negative 8 on 3. Two positive numbers, but x greater than 0, so x equals 2. And then if we pop that into the first, you can see quickly that the y value needs to be 6. So first num is 2, second num is 6. Alright, so that's the end of part 1. So the next part is multiple choice. So the average rate of change of this function over the interval 0 to 4. I wonder if this is quick to do by hand. So 0 goes in, 3 to the 0 is 1, so that's going to be 2. 4, 3 to the 4. Nah, let's do it on the calculator stuff. 3 to the 4, I think it's 81, but okay. So the first thing you should do is run a shift, define f of x equals 2 times 3 to the x, and then what I do is shift divide. We've got f of 4, take away f of 0 over 4, 40. That probably was faster on the calculator. Okay, this one, if that is our function, then dy dx equals. So you could again expand this, but I reckon we just diff that on the calculator. So shift minus for diff, 1 over x squared, x take 1 over x. Where is it? 3, there it is there, D. For the graph of that, the coordinates where the tangent is parallel to the line y equals negative 4 are. Okay, so what we're going to do for this one is diff this thing here. Okay, so that's our gradient function. Now we're going to ask the gradient function, so shift equals for a solve. When is it? So when is the gradient function equal to negative 4? What values of x? And it goes x equals negative 3. So it's one of these ones here. Then all we'll do is pop negative 3 into the original function, and it goes, I'm 6. So the answer is B. Now, how would we test this out? No, we won't. Let's just trust that. Okay, x equals 4. The graph above shows the function g. It is true that g of x, one-to-one function? No, because fails the horizontal line test. Is differentiable for all x is an element of real numbers. Well, it's not continuous, therefore it's not differentiable for all real. Is continuous for x as an element for a real positive? Yeah, definitely, it's continuous for this point here, so that's it. Let's just rule that out. It has a maximum value of 4. It's got a local max at x equals 2, y equals 4, but the absolute maximum is infinitely close to 5, so definitely not. Is differentiable over negative infinity to 2? No, because it's not continuous there, so no, it has to be C. If the curve of the equation that has a stationary point at x equals negative 2, then A must be. Okay, so again, I do this one on the calculator with a shift define f of x equals x squared plus ax plus 5. So let's get the derivatives. So shift minus for diff, shift 8. I'm going to stop using my keyboard to type this stuff in. So is that. So there's its gradient function, and I know that it has a stationary point at x equals -2. So what I'm going to do here is go shift equals for solve, ants equals 0, so the gradient is 0. Can you solve for a with x equals -2? So basically what this will do is set the derivative to 0 and solve it for a when x is -2. A is 4. Okay, the average rate of change from 6 to 8 for this function here is, so again, just define that, a over x take 4, shift divide f of 8, take away f of 6 over 8 take 6 is 2. 1/8, I think. Negative a on 8. Okay, given that h is differentiable at x equals 1, the values of a and b respectively are. So if it's differentiable, it's got to be continuous. So that means that if I pop x equals 1 into this, -1 plus 8 plus 4, 12, 11. So that means that 11 is equal to x squared plus 1 goes in here, a plus b. So what I've done basically is I'm trying to make them continuous. Okay, so I know that this function here is equal to 11 at x equals 1. So this one has to as well. I think I might have stuffed that up. Oh, why did I put x squared there when I'm putting 1 into that first function? So that should be 1. So it's going to be 10 equals a plus b. All right, let's just check that to see if I've done that all right. So 1 goes into this function here, and we've got -1 plus 8 is 7 plus 4 is 11. So this function here is 11 at x equals 1. We've let this one equal 11 at x equals 1. Okay, so we've got that. And then the other thing we know is that to be differentiable, the derivatives have to match up. So what I'll do is I'm going to get the derivative of this, which is -2x plus 8, and find out what it is. So I'm going to bang in x equals 1 into that, which is 6. So basically the derivative of this one needs to be 6 at the point as well. So we'll pop that in by getting its derivative. So it's 2x plus a is the derivative. And it's going to be 6. So we need the derivative to be 6 at this point. 2 times 1 plus a. A equals 4. B is going to be 6. Okay, f is a differentiable function such that the gradient is 0, f dash x equals 0, and okay, I think this should really read when the gradient is 0 when x equals -1 and x equals 2. So let's just see what that means. -1 2 f dash x greater than 0, so it's got a positive gradient for values less than -1 and greater than 2. It's got a negative gradient between those values. Okay, so basically what we've got is a positive cubic. So there is a stationary point, no. There is a minimum point at x equals -1, I can see it's a max. There is a maximum point at x equals 2, no. No, yes. Okay, Ms. Kerrigan has 14 metres of fencing that she uses to form 3 sides of a play area against a wall to create a space for her boys to play in while she teaches remote lessons. The play area is shown below. Show that y equals, so this is just your standard fare. So she's got 14 metres of fencing, 3 sides. So what we're going to do is go 2y plus x equals 14. And we need to make y the subject, so 2y equals 14 take x, y equals 14 take x on 2. The area enclosed is given by this, so basically y we know is equal to 14 take x on 2. So area A of x is going to be the length times the width, which is going to be x multiplied by 14 take x on 2. State an appropriate domain for it. So just on a quick look, you can see that so I'll just show you. So I'm going to rewrite A of x as x7 take x on 2. You can see here that it's going to be 7x take away x squared on 2. Got a negative parabola, so inverted. So what will happen is, we can see here via the null factor law, so if we go A of x equals 0, x equals 0, -7, that's going to be x equals 14. So x is an element from so that's what our rule looks like. So this is A of x versus x. Now again, there's a mathematical argument to suggest that this is okay, which is fine. So we accepted both. Use calculus. So use calculus to determine the maximum area enclosed by fencing and the dimensions of the play space. So you had to use calculus. All right. So what we need is, we know that A of x is equal to this. Okay. So all you really need to write is A dash x equals 0. The derivative equals 0. All right. So now I'm just going to go to my calculator. Equals our function x times 7 take x on 2. What I'm going to do is diff that. So there's my derivative, and solve it. So shift equals ants x equals 7. Okay, so use calculus to determine the maximum area enclosed. So A of x equals A of 7 equals, we're going to pop it into here, 7 times 7 take away 7 on 2. It's probably an easier function to put it into. It's looking pretty nasty. 40 3.5, 7 times negative 9. Oh my god, mental blank here. This is 3.5 from 7 is 7 on 2. 49 on 2. Hallelujah, we got there. Meters squared. So this is using calculus. That's that part there. Maximum area. That. Dimensions. So we're going to say the length is x, 7 meters. Width is this part here, 7, take away 7 on 2, 3.5 meters, or 7 on 2 meters, fine. Okay, an above ground roller coaster at Luna Park is modelled by this rule, so let's just define it. Okay, what is the height of the roller coaster at the start of the ride? For 1 mark, I'm going to do f of 0. Okay, you don't need to write that, but that's what I'm doing on the calculator. State the values of t for which this model is valid, correct to the nearest second. So I just need this, so we need it basically to be valid from there to there, and it's to the nearest second, where t is the time in seconds. So all we'll do is go f of x equals 0. So solve. Correct to the nearest second means we got to drop that thing into decimal. All right, now the other thing I've just done here is I've used f of x, and the function is called r of t. So just note that you've got to be consistent with the function names of the question. So this is r. This is why it's best not to write this stuff down, because if you do write it down, it's wrong. So this is r of t equals 0, t equals that. So to state the values of t, t is an element from 0 to 130. T is the time in seconds after the ride begins. Should we include those endpoints or not? T equals 0, I think we do. Use calculus to determine when the roller coaster reaches its maximum height. So all we need to write down to say that we've used calculus is r-t equals 0. That's using calculus. Now we go to the calculator. We diff f of x. So there's the derivative. Solve. Ants equals 0 for x. So we get 2 solutions, maybe 3 even. No, just 2. T greater than 0, therefore t equals 84 seconds. So use calculus to determine when the roller coaster reaches its maximum height. It reaches its maximum height there. It can't be the negative one because negative time. State the maximum height of the roller coaster correct to 2 decimal places. So I know that the maximum occurs at this value here. So all I'll do is pop it in. Make sure you grab all of it. So 72.31 meters. The roller coaster ends when it reaches a platform 10 meters above the ground. Bang. So all we need to do is let the function, which is r of t, equal 10. So solve f of, I'm getting confused with all the function names. F of x equals 0 for x equals 10 for x. So 0, that's as expected. -2, we don't need that. And 127 is our answer. .127 seconds. The end section of the ride is too steep and can't support the carriages. It's replaced with a new section modelled by this. Where and when does the new section of the ride join? So what we would do is go r of t equals s of t. Solve f of x equals so t equals -75, t equals 100, but t greater than 0, therefore 100 meters. So at 100 meters, they're going to be the same, well, they're going to join basically. So that means that they're continuous. Verify that the two sections of the ride join smoothly. So what we're going to do is test the limits of the derivatives. So lim as t approaches 100 from the left. Now the left function is going to be r of t. Okay, and then we'll do the same limit as t approaches 100 from the right, but we'll test s of t. Okay, so let's go with diff again. And what we'll do is ants with x equals 100. And it says that the derivative is this. Now, they should be derivatives, not the original function. So what I've done is tested f of x, and it says that the gradient is that. Now I'm going to test s dash t. So if you imagine the derivative of s of t is going to be -0.947, that's because it's a linear function. So what that means is both of them have got the same gradient. So we're going to say the lim as t approaches 100 from the left of that is the same as the lim as x approaches 100 from the right. Therefore, smooth join. Done. All right, so I got that done in 44 minutes with a bit of faffing around, but yeah, came in a bit under 50 there, so that's all right.